Hello, this is David Sloan Wilson for Evolution, This View of Life, the magazine that approaches anything and everything from an evolutionary perspective. I am pleased to introduce Dennis Embry as our new editor of the Mind section of Etwall. Hello, Dennis.
Hello, David. I think I'm a good selection for being the Mind editor because I have a high forehead. So I don't know if that's associated with any increased intelligence, but it's certainly associated with male pattern baldness.
There you go. So, and as the viewer can tell, we go back quite a long ways. And
Yes.
actually, you're a character in my book, The Neighborhood Project. So, Dennis, tell us a little bit about your very interesting educational background, including how you became a scientific entrepreneur and how you basically became evolutionary as part of your intellectual odyssey.
Oh, that'd be great. I think my entrepreneurial stuff stems from even when I was 7 years of age selling paintings door to door and learning that people would actually buy things from me, and a nickel or a dime, 15 cents or 25 cents for a custom order for a picture in 1957 was a lot of money, and I used that to buy my first banana split, which promptly made me sick. But that entrepreneurialism, I think, also is what drives me to think out and find the connective dots in science. There's always another hill to look at, another adventure to see. My education is a sort of interesting combination of things. First off, I'm diagnosed as educably mentally retarded in the state of Arizona, which I find amusing, and I think not. That's another story. But I wanted to be in politics when I was a young person, and I became a U.S. Capitol page, and that was a wonderful experience. But one of the conundrums that existed for me in politics was that I wasn't sure that you could also think about science and be a political person. I wanted to bring the best knowledge to the political process, and I witnessed that not very many people were able to do that in the House of Representatives, and that was when it was actually a rather nice place,
Yeah,
and people were.
It only got downhill from there.
It's not quite the same.
And there's no pages
days
anymore, right? That institution went.
There's no pages. That is just like a horrible thing because I had to learn to live on my own. I became even more acquisitive about knowledge. I made lifetime connections. I learned that I could survive on my own, which I was fundamentally doing anyway because of my parents' disabilities and addictions. But taking it away, and then they took it away basically because of concerns about in loco parentis. And all of us as pages, when we went to visit the new dormitory and so on, we were horrified because they were treating the pages as if they were like 4 or 5 years of age. And of course, when you treat adolescents that way, they will rebel. And we had very, very few problems with kids getting into trouble when we were pages, and we lived in boarding houses. Anyway, I went off to college, and I had a great undergraduate education, and I had a dual major in American Studies and American Intellectual History. And my initial senior honors paper was about the role of lead affecting race relations in America. Now that's a pretty unusual topic for a senior honors paper in history because it's combining a biological thing and looking at toxins in the environment and political things and murders and race relations and addictions and things so that brought me into issues of, what does lead do in the brain? Why are African Americans more likely to absorb lead? What's happened culturally in all of this? And my senior honors advisor gave me a B+. And he later he went off to do a sabbatical at Harvard. And I went to see him because I was thinking about going to Harvard. Decided not to. They served us salads with caterpillars in the faculty lounge, which was funny. But he said, Dennis, your senior honors thesis was the most interesting and novel and different senior honors thesis that I have ever had. And I had no way to assess its quality because I knew nothing about what you were writing. And I think that that's been the sort of mark of what I like to do, is to go right to the edge of what is known in both history and psychology and law, psychiatry and medicine, and try to find how these things fit together and how we could make the world better. And I love the title of this section of the magazine, of Mind, because we humans have the ability to think and create a future that we might want, that we might desire. I think that's rather unique in the animal kingdom. Other creatures, of course, build a future, but I don't think they have a mind about what it is that they're building.
Right.
So off I went. I thought I was going to go to law school, decided maybe law school wasn't the great thing and politics wasn't the great thing. And I think at that point I was also probably dealing internally with some issues of being a gay man. And I fell into studying applied behavior analysis and at the University of Kansas. And that was an amazing adventure. That taught me to think in precision ways about measuring human behavior, measuring the context of human behavior.
And just to provide some context, ABA is the applied wing of the Skinnerian tradition, right?
Yes.
And at that time, the Skinnerian tradition, once dominant within academia, had been sort of ostracized within academic psychology, but was still a very strong field in the applied disciplines, and
yes,
always known for its methodological rigor. Am I right about all that?
Absolutely. And I tell people in my training, I became a plumber of human behavior.
Uh-huh.
I knew how to get the stuff cleaned up, because behavior analysis teaches you to see things with rigor. And our folks, for example, in evolutionary work, particularly those who work with like insects or animals, they learn to have very precise measures of whatever it is that they're looking at. They're measuring context and they're measuring interactions, and so they see the fluidity and the variability actually operating. Most psychological or behavioral scientists do not measure directly variability. They estimate variability through randomized control group methods, but in evolutionary work and in the painstaking bench science that biologists go through, you're actually measuring variability moment by moment by moment. And I believe that's absolutely crucial for understanding how to build things and make things.
Right, so connecting the dots between ABA and modern evolutionary psychology is something that needs to be done. It was not done for you, but
yeah, no, it wasn't, although it was very clear from the writings of B.F. Skinner that he was well on to the notion of selection by consequences, which Tony Biglin and I and other folks think of as sort of a meta-theory about how life, how organisms, how cultures, how communities operate, how businesses operate, how dyadic relationships operate, how genes are selected. So there's this sort of familiarity from selection by consequences works at a synaptic level.
right.
It works in the classroom. So that's, I think, probably one of the first connections I had, but I really hadn't thought about it in a mathematical way and in a sort of elegant fractal way that now I see it in.
Right. Okay, great. So continue.
Well, as I went on, I began to ask questions like, one, can we actually make large-scale change? Most of my colleagues in graduate school were interested in small things, and I kept looking at this technology and going, wow, this is a pretty powerful technology. I mean, I can go in and I can change this kid's behavior, and I can change the mom's behavior, I can change the teacher's behavior, and, things are better. Why don't we do this on a big scale? So I kept pressing the envelope to say, why can't we do this bigger? Why can't we do this bigger? And fortunately, my advisor, Don Baer, was very protective of me and would give me every opportunity to do the big things. But as you do big things, that forces you you come straight up to issues of here's another field, here's another, in your terms, a little island in the Ivory Archipelago, and oh my gosh, they actually know something over here, and that doesn't mesh at all with what I know. Now they've got science, they back it up. You know, maybe there's a connection here, but of course most of the time the people are arguing and saying, you know, these things are different, they can't possibly, you know, only one person must be right.
Dennis, let me just interrupt you. It's not going to work well for our interview if your Richard is in the background. So,
I'm going to leave. Okay, you'll leave.
I don't know. Hello there.
Okay.
I'm going to bees.
You're going to bees? Okay. He's going to go stuff boxes.
Okay. I hope I didn't offend anyone there.
Pardon?
I hope I didn't offend anyone there.
No.
Okay, so back up about a minute. So let's see, where were we?
So so soon I started in trying to go to scale, to think about doing things big, which I had actually done as an undergraduate student. I developed the teacher assessment or student assessment of instruction for the entire university, and as a junior I sat on the promotion and tenure committee, which was a rather unusual thing, and the Student Senate actually paid for the administration of these things. I had to learn things like factor analysis and so on, and I thought this was a very good thing, and it was exciting. But my limits of my knowledge then were also challenged when a professor, a young professor, called, and he was in utter tears because his student ratings of his class and his instruction were abysmal. I think he would have a turnip would have gotten better ratings, and I realized that I had no idea what to do for him, and that opened my heart in compassion because he clearly wanted
we're gonna have to. This is. Let's see. What do we? Okay. Let's. We got to redo that again then because.
Yeah. So one day, a young professor called me, and his student ratings were abysmal. I mean, they were just ridiculously bad. And I think a turnip might have had better evaluation scores. He was crying. He wanted to know what he could do to improve his instruction. I didn't know, and my heart opened in compassion, and I realized one of the grave problems of human society is when we evaluate people and we don't give them a way to improve, and we give them no direction, we teach learned helplessness. And I think I made a spiritual commitment at that point that never again would I engage in things where I evaluated people and gave them no mechanism to improve. And that set me on this course, I think, of applied behavior analysis, of learning tools to use, thinking about technologies from other disciplines, and starting really this journey of integration. My graduate work also forced me to think about a novel problem that no one had ever really thought about. It's like one of those accidents of fate, or maybe not. One day, Don Baer gave me a letter to answer. And it was a letter from some people wanting to know what to do to prevent pedestrian accidents to very young children. And Don said, I haven't a clue, and what to do. And at that point, I actually ran all of the literature searches for all of the grad students in 3 departments and all of the faculty members, because I wasn't able to go use the computer system up at the library to do these electronic searches. You know, it's common today, but then it was an extraordinarily rare thing. So I was quick at this. And so I went up and I discovered, oh my God, this is the 3rd leading cause of death in the United States. And there isn't a single experiment on what to do to stop it. And at least in this country, there had been one study in Sweden that had showed that their intervention had resulted in more kids being killed as a consequence of their educational and treatment strategy.
More kids being killed.
More kids being killed. That's always a warning. We assume when we start to do something in the name of a good that the good will happen. Well, adverse effects are almost always a possibility of any human endeavor. And that reminded me to be humble in that respect, that everything I do, I've always tried to measure for adverse effects, which is not common among behavioral scientists. But that was the reminder for that principle. And so it set me in motion, and I realized I had to do much integration. So, for instance, I had to study the ecology of the accidents. Actually, no one had ever gone out and directly observed accidents or near misses. They'd always written up police reports, which was an archival thing and prone to all sorts of error. Like the police officers have said, oh, the kids were killed crossing the road. Well, when we went out onto the places that the epidemiological data had suggested kids normally got killed, we discovered the kids never went across the street. They actually just played. They went into the street many times an hour. So that was very clear, and the problem with the Swedish intervention was that they taught kids to cross the street mid-block. The kids could learn the topography of the behavior. They stopped, they looked right and left, and then they went directly out in front of the traffic because they couldn't judge the velocity and the size and shape of the objects. Now, so that caused me to have to think about issues of developmental psych. Now, that was anathema in applied behavior analysis, to think that there was a sort of programmatic way that the mind unfolded. Well, it was clear after I read the literature that it did unfold in a pattern. Now, what caused that? Was it genetic? Was it environmental? Was it some, operant shaping thing? That seemed unlikely, given that this pattern seemed to be worldwide. The probability that everybody would shape the same behavior across the world, that just seemed stretching to me. And so we then had to figure out what to do about the developmental things. And we had to do this in the laboratory. We took it from small steps. We created a little thing to see if it made a difference. We read storybooks to kids because that was an ecological intervention that we could do. And we knew that every parent, we found that changed kids' behavior and parents' behavior to some extent. Then we had to figure out how to bring it to scale, how many people. Eventually, I was able to take that to the entire country of New Zealand and bring that to bear as a national intervention and study the process of social marketing and engagement. So what I've been lucky enough to do in my career is to take a problem literally from the review of the literature, the laboratory, environmental epidemiology, looking at the development of the brain, the mind, looking at the behavioral things, the ecological and the political factors, the cultural factors, and then the marketing factors. And I've been able to do that now multiple times. And each time I do that, I kind of keep this fractal model of moving up and down the scale, thinking of all of the issues, and thinking about literally the biology and the culture and the neural networks and the contingencies of reinforcement, the selection by consequences, to build something that might be practical. That's what I do for a living.
As the head of a company, PAXIS, describe PAXIS just a little bit.
Well, we call PAXIS the plumber of behavior. You got a problem, call us. We have rotor-rooters to fix human problems. But we don't just, I say, well, I could do that as a licensed psychologist. Okay, you got a kid and it's got a problem. I could give you some advice about that. But we get called typically by governments, either municipal or tribal or provincial or state, and sometimes national governments, to solve problems like a methamphetamine epidemic, problems of ADHD, problems of child maltreatment at a population level, violence prevention at a population level. So we essentially design, test, and market solutions to real-world human problems. I joke with people that the world's problems are not silicon-based. The world's problems are carbon-based. Our audience here will get that. Some people are a little slow if they don't know that life is made of carbon, not silicon.
Well, let's take two of your current projects.
Yeah.
And to describe them and accentuate where evolution comes in, because evolution, of course, comes in at multiple junctures. You've mentioned the Skinnerian phrase, selection by consequences, which emphasizes that individual learning and cultural change are themselves evolutionary processes. Then we have genetic evolution, which is a layer, another layer, which creates a sort of a more stable substrate to human psychology, and which has a mechanistic basis in the mind and brings us all the way down to the neuronal level. Then we have the fact that evolution is a fast-paced process, and so actually genetic evolution is a fast-paced process, and so we can see that happening in addition to cultural and individual psychological change. And all of that gets wrapped up into kind of a toolkit that we and happy to have you involved in the Evolution Institute, that we're trying to present as a policy toolkit. And so that's another great asset that you have. And so let's take our first topic, dear to both of our hearts, the good behavior game. Tell us about the good behavior game.
It's an amazing strategy. So imagine walking into a classroom and you see it completely chaotic. We have entered classrooms where the rates of that chaos, which you can measure in 3-second, 10-second, 1-minute intervals with varying degrees of inter-observer agreement, as high as 1,400 disruptions per hour.
I didn't know it got up that high.
That's a little on the kind of like there must be something in the water that's just gone completely awry. But ordinarily, we see in classrooms all across North America rates of disturbing, disruptive, inattentive behavior between 200 and 400 per hour. Rarely do we see it much less than 100 per hour. That would be a very good classroom under normal conditions. Now, that looks, makes us feel uncomfortable. We don't want to be in the room. I think, how the hell does the teacher deal with this? The children are crazy today. All of those thoughts go through our mind. The question is it an important thing? Does it have evolutionary significance for those micro behaviors? Do those micro behaviors have evolutionary significance in the development of a child's own personal toolkit for solving problems of life? The answer is, oh yes, it does. So for example, if you take a child who is already rated by kindergartners or by a kindergarten teacher to have behavior problems, David, since you're here in 4th grade and I have told your mom that you have problems of sitting still, you keep jumping up and blurting and poking other kids. You've poked Tony and you've poked Jerry and you've called them names. This is just not acceptable, David. Do you understand that's not part of our rules here? He goes, yeah. And you flip me off, okay? And then you go poke somebody else. Turns out that if you take a high-risk kid like that, rated in kindergarten, and then you randomly assign them to a 1st grade classroom that has a low rate of those disturbing behaviors versus a classroom with lots of those disturbing behaviors, a kid who's dropped into that very disturbing classroom, 1 out of 3 of those high-risk kids will grow up to engage in criminal behavior. But if you drop that kid in a peaceful classroom, only 1 out of 70 will go on to have criminal behavior.
And
now,
that study has been done.
Yeah, it's been done. That's a baseline study done by my colleague Shepard Kellogg at Johns Hopkins. Now, we've also seen that same kind of pattern of behavior in parent-child relationships, lots of disturbing things. Jerry Patterson calls it the cycle of coercion in home things. It's a similar process in a school setting. So, and I model this, there's actually a mathematical law, which our evolutionary people will understand as the maximal foraging law. In behavioral things, we call it the matching law. So I model this for teachers. Imagine there's the good Dennis twin, and there's the evil twin of Dennis. Devilish Dennis and godly Dennis. So godly Dennis, he sits in his first grade classroom, and he is so studious, and he follows every rule. He's very kind and helpful, and he does his work. How often does he get I ask teachers, how often does he get reinforced by his peers for being good? And they go, never.
Never.
And I said, in inner city school, he might even be teased or taunted for, you're white, okay, traitor, so on. Okay. And then I say, and how often do the adults in the school reinforce him for being good and on task and all those things in an hour's time? Maybe once or twice. Okay. Now, consider devilish Dennis, his evil twin. So he's sitting in the platform and he's doing all kinds of things. How often does his peers reinforce him for being bad? Oh, all the time, because the audience is laughing. And that's exactly what happens in the classroom. Then I said, and what do the adults do? Well, stop that. Stop that. I told you, I'm going to call you the principal. And then you get worse. Okay? You can see the mathematics of that. That's a saturation type formula in the matching thing that is just universal as a fractal. That law predicts all of these adverse consequences out in a long period of time. But the game changes that. Now I ask people, where is the problem? Is the problem in the teacher's reinforcement or in the peer reinforcement? People go, it's the peers. Yes. And you don't have a tool for that. Going to yell and scream at them too? There'll just be more of that. So the game creates, it's essentially soft team competition, okay, and all of throughout, I think, natural history of humans in our ancestral environments, we put kids together on cooperative work. Now you do that in a classroom. The kids are on typically 3 teams. You also create a vision of a most wonderful classroom, what you would see, hear, feel, and do more of. And the kids are quick to make that list. And that list will be the same in any school building in this country, in Canada, and any other place I've ever done the exercise. Now, the language might differ. In some places in Canada, the children will respond in French. But the concepts are the same.
So some of the evolutionary points to make here, first of all, people are in groups, the kids are in groups. There's some between-group competition of a soft, nice variety.
Yep.
There's a consensus so that the kids are doing what they think is right, not what somebody else tells them to think is right. And all of this is basically emulating the social conditions of small-scale human society, typical of hunter-gatherer society. So what we're doing is we're kind of emulating an ancestral social environment that doesn't exist in a modern classroom. That's what we're creating through the device of this simple cooperation game, right?
Absolutely. And now you have one other piece to it. You also define what they, or a couple of other pieces, what they would see, hear, feel, and do less of. We give names to these things to create a relational frame, which is another kind of evolutionary advantage that humans have. Humans can construct a concept that is portable and can be used then to identify new situations and applications. So
and to make
the
another
kids,
point of connection, just for our listeners, this has to do with symbolic thought, the nature of language, and really the thing that differentiates us from all other species is our capacity to create these imaginary mental worlds, which in one branch is called relational frames. But that's what we're doing here, is we're basically part of creating the culture, is creating this symbolic system.
Absolutely. So the good that the kids are creating, we give it a new word for them, PAX. And we give a new word for the bad that they're trying to sweep away. We call that spleens. And there's actually some nice little evolutionary fine-tuning that's going on here. When the children break a rule, typically the teachers scold them and they go, I told you, David, not to do that. How many times have I? And of course, my face is in a complete universal recognition among all humans across the planet as, he's mad. He's irritated. He's angry. You know, and that creates shutdown and all sorts of things. So by giving a word that changes the facial gestures of the adults, that's a spleen, David, when you call me a name. Okay, that makes you kind of smile. It helps actually from physiological research. When you do that umlaut sound on the face, that actually elevates some of the stress hormones inside of the human body. But now we've sort of softened and dampened all of that. Plus, these are now part of the symbolic thing. You don't only have to have two rules: increase PAX, decrease spleens. So any new event happens and the kids go, and you ask the kids, you don't have to tell them what the rule was. You just ask, was that class, was that PAX or spleens? Instantly, they make the classification. And that is so powerful in getting to automaticity of making choices in new situations. So you play the game, the teacher goes about his or her business. You teach, lessons, whatever. And if one of the team members says, your mama, that's a spleen. But not a spleen for you as an individual, but for the team. And if somebody else over here goes, oh, nana, nana, napu, they got a spleen, that's a spleen for that team. So we're now reducing the accidental attention to negative behavior within teams and across teams. The timer rings, you count up the spleens, and if the teams have 3 or fewer spleens, the teams win. And by the way, all teams can win. So again, that's part of the evolutionary thing, not hard competition, but soft competition to work toward a common goal. The kids now share in a mystery motivator. Typically, it's some silly thing. I can show you videos of them having a 10-second giggle fest. They're getting to literally in the classroom with the premier of Manitoba, the children had a mystery prize of squatting and moving around the room, waving their arms like wings and quacking like a duck. It was quite delightful. The premier, however, did not actually join in the prize, which I would have rather liked. But that's also teaching self-regulation under conditions of excitement. But the game itself is teaching voluntary control over a tension for a task, for an intention, a delayed intention. And within seconds of implementing the game, you see the disturbing, disruptive behaviors fall typically from something like 200 to 400 down by less than 75% of what the baseline was. And as the kids get practiced, they can play the game for a longer time, and they can still keep the level of spleens at that level of 3. So you can walk into a classroom, and suddenly those kids are now completely engaged, on task, completely happy, and nobody is jerking their chain or yelling and screaming at them. They are working.
So it's a transformation, and there's a longitudinal study in Baltimore in which this game was played in a randomized control design, and some first and second grade class, not others. And then those kids were followed as a cohort, and they're now in their 20s, right? And
yes.
The only manipulation was this thing that took place in the first and second grades. And describe describe the differences that exist now when these people are young adults.
There are extraordinary differences, and of course people go, that cannot be true, but it is true. So for example, first off, reading and test scores went up in first grade if the teacher played it well. ADHD and oppositional defiant disorder are averted in middle childhood, 3rd and 4th grade typically. Conduct disorders are averted in 6th grade, and initiation of tobacco, for example, is nuked, especially among very high-risk aggressive kids who normally migrate very rapidly to tobacco use. Alcohol initiation is reduced. And by adulthood, what you see is about half the rate of serious alcohol addictions among the kids who got the good behavior game. You see a dramatic reduction in antisocial personality disorder and violent crime among the kids who are particularly aggressive. If memory serves, I think 85% of the high-risk kids in the control condition who went on to have antisocial personality disorder and criminal involvement versus only something like 36% of the high-risk kids in the good behavior game. Depression is reduced. Suicidality is also decreased significantly. It's the only elementary school strategy at a young age that reduces suicidality. All addictions are reduced. College graduation is increased, and university entry is increased. So these are astounding long-term effects.
All for an intervention that took place in the 1st and 2nd grade.
Yes. And one way of thinking about this, I believe, is that we've known for some time that the early peer context, after about 4 or 5 years of age, becomes exceedingly important in shaping long-term developmental outcomes. And if you think about that from an evolutionary perspective, your parents can only have so much regulation of your future, but it will be your peers to a significant extent as you enter into adolescence and young adulthood, who will be the larger predictors of your survivability and reproductive success, economic and resource success, safety from predators. It's your peers that determine that. So that if you're dropped into an early peer environment that looks like armed warfare, perhaps you should develop the armor to succeed under that situation. So I view things like oppositional defiant disorder and conduct disorders and even substance abuse not as mental illnesses or behavioral illnesses. They're in fact evolutionary adaptations to when the world goes nuts.
Yeah, and that's a very important theme that so happy that you're going to be editor of Mind Section, because the idea that what seems pathological is in fact adaptive in the evolutionary sense of the word is a profound insight. It's a very simple insight, but it's profound, that when people are behaving in ways that are damaging for others and even damaging for themselves over the long term, in fact, that can be something which is highly adapted to adverse circumstances, although also tragically mismatched. So it's a combination of an adaptation hypothesis and a mismatch hypothesis, and that should become part of the common vocabulary of someone who uses the evolutionary toolkit, but of course it's foreign to the many people involved with at-risk behavior.
Yeah, and that was in my work with the Evolution Institute. Mismatch was not part of my initial toolkit. I understood the adaptation, and the adaptation came, the understanding of that actually came for me whilst I was on special assignment as a GS-15. For people who know about the civil service, that's basically the highest level you can be in the U.S. civil service and not be a political appointee. I was appointed by Secretary Cheney on special assignment to go to Germany to investigate why so many children of deployed military were having complete meltdowns during the first Gulf War. The prevailing hypothesis was the children were mentally ill. So I am there, and my job is to report back to the Secretary what they should do. I visit maybe, I don't know, I was in different installations every day and interviewing kids and teachers and parents and witnessing things and observing things. And literally, as I was sort of reflecting on the weekend, I came to realize that all of the behaviors that were being reported that the children were doing, and you can find the list in the DSM-IV diagnostic manual, everybody was saying that these children had gone crazy, and I'm going, okay, so you're young children, and now you're clinging and regressive. Oh, and what's the threat? From other human beings. So, the best thing I could possibly do would be clinging to the person who could help save me under conditions of threat. And the aggression and the loss of reward delay and the early sexuality among the teenagers. All of this made perfect sense to me. So it was, because they were urging me to say that this was a mental illness, and I faxed back, this was before the email, to the Secretary's office, no, this is not a mental illness. This is an evolutionary adaptation to when the adult world has gone crazy in terms of protecting children. Now, and what's a mismatch also is that the children were not directly threatened, but they were seeing the threat symbolically through the eyes of television and other kinds of things.
Right.
And when I met in the Secretary's office, which was an amazingly interesting thing, you go to the Secretary's office and there's only one person there, the Secretary, yourself, and the adjutant who takes notes. And I made my report, and Mr. Cheney actually at that point was on the Hill, so I met with the Deputy Secretary, who was his second in command. And I observed what I saw and what I thought, and he said to me, Dr. Embry, I believe you are exactly correct. And he said, the trouble in my mind is I believe that in the next war, the cameras will be on the bullets. And you know what? He was exactly right. So we've seen much higher rates of these disturbing things from the chronicity of the wars in Iraq and in Afghanistan. So that's I think part of what I want to bring here is not thinking about things as disorders, but thinking about them through the lens of evolution and adaptation, and how they might serve a purpose and how we structure the environment and consciously.
Well, let's quickly bring in, there's more to say about everything, but let's quickly bring in another piece of the puzzle, which is even more clearly a case of mismatch, and that's the omega-3, omega-6 story. So tell us what that is, but also some of the recent science that actually demonstrates how we can make things better based on this knowledge that we have. And in this case, this is a clear mismatch between our current environment and our genetic ancestors' environment. There's not much about cultural evolution in this story. It's a genetic mismatch story.
Yes. About 12, 15 years ago, I started reading about the role of omega-3 in mental disorders and illnesses. And my first thought was, oh, this is, since I live in Arizona, this is rock crystals, vortexes, and alien abductions. It made no sense to me. And then then a couple of randomized trials came out, and those were impressive, and I read I always read the bibliography to see the genealogy, the evolution of the piece. And I kept seeing this one name, a man named Joe Hebden. And I eventually went to see him. He's at NIH. He's the chief of the molecular membrane laboratory at the National Institutes of Health. And he gave me a whole day to explain all of this. So here's the sort of short end of the story. The brain is about 60% fat. And the fat composition is particularly interesting. Most of that fat is polyunsaturated omega-3 fatty acids, some particular kinds, docosahexaenoic acid. And for our viewers who may not kind of understand some of the structural parts of the brain, the neurons or the cells hold in water-based molecules, but the wall to keep the water-based molecules is composed of lipids. Now, what we discovered was that so much of the prefrontal cortex of the brain was this omega-3, DHA. Where did that come from? People started, land animals, there's not enough in a land animal to build the brain in dietary intake. So this must have come from someplace else. So the intriguing part from the anthropological and evolutionary side was that people started to see that so many of our ancestors evolved under conditions of sort of coastal areas where they were in Africa, where they were able to pick up and eat African carp, African tilapia, and crustacea, which are all relatively high in omega-3 fatty acid. So suddenly there was a clarity of where the food chain could have come from. And then in the late 1970s was a piece of an extraordinary finding that did not fit anything we knew. We knew that saturated fats caused lots of heart disease things, but the Greenland Inuit had among the highest rates of consumption of presumptive saturated fats, but they had almost no heart disease, and they had relatively low rates of mental illness. Well, there was nobody knew what to make of this, and you know how academics can get when a new thing comes up. Knives get sharpened, people die by 1,000 cuts, and some people are left standing, and some hypotheses are not. But it was peculiar because there was less heart disease and less mental illness, and it took a lot of understanding of what was it that was different. Eskimos, for example, or traditional folks, they eat 9 grams a day of omega-3 fatty acid, which is an amazing amount. So over time, it built up in the epidemiology that as you see declines in the consumption of omega-3 in population, so let's think naturally, where's omega-3 common in the diet? Japan, Iceland. So what are their all-cause mortality and morbidities look like? Much lower. And so then you look at places where they have very little omega-3 in their diet, and you just, like America and Israel, but the Israelis are divided. The Arabs have they have low omega-3 and high omega-6, and the Muslims, practicing Muslims, have high omega-3 and low omega-6. Very interesting. And so every level you look at in disease, heart disease, depression, mental illness, homicide, suicide, you see this gradient of the more omega-6, which is found in soybean oil, cottonseed oil, corn oil, versus omega-3, found mostly in fish, but in other sources, nuts and some green vegetables. You have better health. Now there have been experiments on this of actually changing the diet, and what we see now in randomized trials of when you increase omega-3 prenatally, for example, there's less postpartum depression, there are better cognitive and perceptual outcomes in children. Now it varies on the kind of nature, the formulation of what people get. We also see that there's in experimental studies, for example, this reduces or averts psychosis. There's a phenomena, for instance, psychosis or a schizoaffective disorder has a gradient with the more north you go or south you go of the equator, schizoaffective disorder rises. If you are dark-skinned, then that rises faster. But if you eat oily fish, then that gradient goes much lower. What's naturally occurring in fish is vitamin D. So this is just an example of one of the components of eating fish that is very protective of immunological things and the expression of genes actually in the brain. So now what we have is experimental studies, randomized control group trials showing that giving people omega-3 and or reducing the ratio of omega-6 in their diet clearly improves health. And there's a significant indicator that this improves mental well-being and reduces mental illnesses. So what we may have today is, and all of this has happened in a very quick time. When my grandfather was born, we would have only consumed about 0.1 of a pound of omega-6 found in soybean oil. When I was born in 1948, people would have consumed about 3 pounds of omega-6. Today, our kids consume about 30 pounds of omega-6 found just in soybean oil, and it's in everything in our current industrialized diet. And to give you an idea of what that means kilocalorie-wise, that's about the equivalent of maybe 150, 175 Super Mac Big Burger meals with the double patty, the cheese, the mayonnaise, salad dressing, the supersized Coke, and a big order of French fries. So it's huge kilocalorie things, and this causes, by the way, an inflammatory response in the brain and the body that's increasing our risk of asthma, diabetes, and obesity. All of this is both laboratory science and in randomized trials. So we have a mismatch in current culture. We have selection by consequences as public policy that these things like omega-6 and the industrial food products are highly profitable, but they're not in service of our kids' development.
Well, describe, Dennis, because a lot of people don't know what a randomized trial is, how this is tested, and so on. And for me, it's so interesting and adds confidence, basically, in the results. So before the interview, you were telling me about a study that was done, and I think in West Virginia, having to do with a whole school district. And
yes.
So describe in sufficient detail how this study was done and what the results were, and then we'll finish up this long but very interesting interview.
Well, the West Virginia, just a minor correction, the study in West Virginia is a replication in process, but the original randomized waitlist control trial was done in the UK with schools. The idea of a randomized trial is that you have a population and you basically flip a coin and you try to match them so that the variability is controlled in higher quality designs. But the beauty of a randomized trial versus some of the traditional single subject designs, which I was trained in, is it allows you to see what if and what if not a particular intervention does over a longer period of time, and that is its important contribution to us in science. So in this instance, what is happening is schools are being randomly assigned to either get or not get omega-3 in the dietary pattern of kids. Now, we used to give in many countries, and still in many provinces of Canada, you can buy omega-3 fatty acids gel caps from the school nurse for $2 a month, and your kid will get that every day, just like Grandma used to do. Here's the cod liver oil, kind of not so flavorful, but the gel caps make it more manageable. So what they found in this particular study,
so
and there are others.
So is an entire school, like a high school or an elementary school?
Yes.
And so the cafeteria food was how was the omega-3 provided?
That was in the study in Britain. It was provided in gel cap form. Now there are studies in process that are actually beginning to alter the construction of the food, and that is being done under military context as the first wave of things because we can control things there, and there's really compelling reasons for doing this. I can describe the nature of those studies.
Okay, so in this school, though, a whole school, the kids would get gel capsules, not in this school. Okay.
And of course, parents have to consent to this and so on. And by the way, it's not a medication, it's a food. So as orange juice is squeezed oranges, gel caps of fish oil are squeezed fish. They just be conveniently wrapped in this jello, essentially, hardened jello. So they got this omega-3 in proper dose ratios. And this has been done with prisoners, it's been done with mentally ill people, with all sorts of, with folks who are at risk for heart disease, but in this case with school children. So what we see happening is the kids who get the omega-3 fatty acid, one, there's less behavior problems in the school, less ADHD symptomatology in the building. The test scores go up for the kids who are getting the omega-3. Reading and writing go up, and I think one of the most interesting ones for me is the pictures, the exhibited pictures of the kids before and after they got omega-3 and the quality of their handwriting. So you see at baseline the kids have handwriting that's just horrid, and then you see a sharpness, and that has, we understand that what the omega-3 does is speed up the transmission of the electrical impulses because it helps form the myelin in the connective tissues of the neurons. So, here's this relatively simple, stupid thing. And 100 years ago, kids didn't have any of this omega-6. They all took omega-3 from their grandmas, making them take cod liver oil. And, our kids were actually pretty smart 100 years ago. And we've been getting dumber by the second. But now this is being repeated in some more controlled studies in West Virginia, which is a wonderful place. And particularly, we have a great story where the children, 3 girls came in after learning some of this, and they decided they wanted to eat sardines, which most of our viewers will go, ugh. But the sardines are actually among the very best fish to do. It's completely sustainable. It doesn't harm the environment. There's no mercury in sardines. It's virtually undetectable because they're little itty bitty fish. They grow rapidly, and they don't accumulate toxins. So the kids come in, and the adults are freaking out because, with the sardine can, it has this sharp metal edge after you open it up. So, oh my God, it's a weapon. We can't have this. So the girls are like, we want to do this. They're 4th and 5th grade girls. And when 4th graders want to do something, especially girls, you really better not say no because they have black and white thinking. So they persisted at it, and finally they got the coach to volunteer that when they wanted to bring their sardines once a day or once a week, that he would take the can when they were finished and put it away in the trash and so on. And so 3 girls started this. Well, it became contagious. And now in this particular school, there are 75 kids who are part of the sardine club, who are eating the sardines. And of course, this is all being scientifically monitored. But one of the hilarious evolutionary things that's sort of been deeply embedded inside of this and not obvious is that the kids went over to offer the sardines to the adults in the building. And they were like, oh no! And of course, what do the kids want to do when the adults make faces about it? Then you get status among your peers for doing this thing that the adults are too chicken to do. So it's become a behavioral contagion to eat the sardines once a week with all of the sardine club. So we're making a little video about this. We actually want to replicate this as a scientific intervention because it has all these wonderful little marks of evolution sprinkled through it that can be manipulated and tested. But it's a powerful thing, and it explains much of what's going wrong in our society, an evolutionary mismatch. And it has a history of humans. It explains so much of how we came to have a higher cognition compared to our primates. It accounts for the fat molecules that have allowed our brain to grow. So it's an elegant story.
It is an elegant story, and our conversation has been great for showing kind of the length and breadth of what needs to be reported in the mind section and what can be reported thanks to your length and breadth, Dennis. And so I want to thank you for becoming our mind editor, and it'll be great fun to work with you and to have this smorgasbord of topics represented on the mind section of Evolution, This View of Life.
Oh, I look forward to it, and thank you, David, for the opportunity. And let us develop one mind about making our minds better.
Okay, that's great. Thank you, Dennis.
You're welcome.